Good morning, my dear students. In this particular video presentation, we will discuss some more problems meant for JEE or for any competitive examination for that matter. The first question meant for today is on determinants. You just see evaluate determinant 2000, 2001, 2002, 2004, 2005, 2006, 2007, 2008, 2009 without actual expansion. That is a question given to you. I should not expand. The expansion goes like this: 2000 into this minus this into this, minus 2001 into this minus this into this, plus 2002 into this minus this into this. That's the application normally. That's the real meaning of expansion of a determinant. I have to take elements of any row or any column and multiply each element with the corresponding cofactor, and I will add. Now I'll move on to the answer directly. What I will do is I'll just apply R2 going to R2 minus R1 and R3 going to R3 minus R1. Let us just see. I'll just leave R1 as it is. And here I mean to say I'll have 4 here, I'll have again 4 here, I have again 4 here. Here I have 7, I have again 7 here, I have again 7 here. Now I'll be able to take 4 as common from R2 and 7 as common from R3. Therefore this will be 2000, 2001, 2002 as it is, 1, 1, 1, 1, 1, 1. Here it will become automatically 20 into 0 since R2 identical R3. I won't say equal. The corresponding elements are equal. I call it as identical, which is equal to 0. Let me just explain once again. This is a question given to you. We'll apply R2 going to R2 minus R1. 2004 minus 2000 is 4. 2005 minus 2001 is 4. 2006 minus 2002 is 4. R3 going to R3 minus R1. 2007 minus 2007, 2008 minus 2001 is 7, 2009 minus 2002 is 7. Now take 4 as common from R2, 7 as common from R3. Then I'll have R2, R3 to be identical. The elements are identical. When they are identical, 2 rows or 2 columns are identical, I mean to say the value will be automatically 0. Now for the final answer becomes 0 automatically. It's a very simple result. Okay, it's not difficult to follow. Here I am using a rule. If I add a particular constant with elements of a row or column and add the elements of another row or another column, the value remains the same. That is one of the properties of determinants. Okay, that is one of the properties. I have to teach that particular property if needed, but I am taking it for granted only for this case. Okay, then next problem goes like this. Just see here. I'll write NCR as CR in the following case. If 1 plus x raised to n is equal to C0 plus C1x plus C2x square plus etc Cn x power n, then prove that you need to prove that C0 C2 plus C1 C3 just check the question. Yeah, etc Cn minus 2 Cn etc will be is equal to 2n factorial divided by n minus 2 factorial into n plus 2 factorial. The proof is not difficult. Just see here. Answer. Just see here. 1 plus x whole power n is nothing but C0 plus C1x plus C2x square plus etc Cn x power n. Name this is 1. Also x plus 1 whole power n becomes C0 x power n plus C1 x power n minus 1 plus etc Cn. You will have this much. Okay, now let me just multiply 1 and 2. Here I will just write this as 1 plus x raised to 2n. 1 plus x, x plus 1 whole, both will be the same. Here I write it as it is. C0 plus C1x plus C2x square plus etc Cn x power n. And here I will write it as C0 x power n sorry, x power n, I write it as xn, I wrote it as suffix c naught x power n. Okay, I'll write it as c naught x power n plus c1 x power n minus 1 plus etc cn. You name this as equation 3. Now general term in 1 plus x raised to 2n will be r plus 1th term 2n cr x power r. In general term is a plus b raised to n is ncr a power n minus r b power r. That's what normally we'll say. Therefore, here I mean to say 2n cr into x power r. 1 raised to anything is anyway 1. Therefore, I write simply x power r. Therefore, here you just see here coefficient of, okay, coefficient of x power n minus 2. I have to think about coefficient of x power n minus 2 in LHS of 3. Just see here. X power n minus 2 means it is 2nc n minus 2. The power n minus 2, therefore 2nc n minus 2 can be written as 2n factorial by n minus 2 factorial into 2n minus n plus 2 factorial. This is the application of NCR formula. N factorial by r factorial into n minus r factorial, which is equal to 2n factorial divided by n minus 2 factorial into n plus 2 factorial. Name this is, let us say, 4. Now coefficient of x power n minus 2 in RHS, right hand side of 3. What do I get here? Here a constant term, here I have to take x power n minus 2 term, okay, which is nothing but c0 c2. Then if I take x here, I will be taking x power n minus 3 here, it will be c1 c3 plus etc etc. I will take cn minus 2 here and constant here, cn minus 2 cn, cn minus 2 cn. Okay, yeah. Therefore this you call it as, let us say, 5. Then 4 and 5 will automatically imply you c0 c2 plus c1 c3 plus etc etc cn minus 2 cn will be is equal to 2n factorial divided by n minus 2 factorial into n plus 2 factorial. Let me just explain the whole lot quickly. Let me just explain. See here, 1 plus x whole power n is given by c0 plus c1x c2x square etc cn x power n. For easy purpose, NCR is written as CR in this particular problem. Also, I can write it as x plus 1 raised to n is c0 x power n plus c1 x power n minus 1 plus cn. Equation 2. Same manner, expansion of binomial theorem tells you. Now multiply the two results. LHS I will write it as 1 plus x raised to 2n. Here I will have it as it is. Name this as 3. Now general term here is 2n cr x power r. In general term of a plus b whole power n is ncr a power n minus r into b power r. Instead of a I have 1, instead of b I have x. Now therefore coefficient x power n minus 2 in LHS of 3 here will be, the power is n minus 2, therefore 2nc n minus 2. 2n factor by n minus 2 factorial, 2n minus n plus 2 factorial, 2n factor by n minus 2 factorial, n plus 2 factorial. Now coefficient x power n minus 2 in RHS of 3. See here, if I take constant here, I will be taking coefficient x power n minus 2 here, c0 c2 plus c1 c3 and c2 c4 and so on. And here if I take cn minus 2, I will take the constant here, cn minus 2 cn. That is the last term finally. Now for compare 4 and 5, coefficient x power n minus 2 in LHS, coefficient x power n minus 2 in RHS, both will be the same. Therefore c0 c2 plus c1 c3 etc cn minus 2 cn will be automatically equal to 2n factorial by n minus 2 factorial into n plus 2 factorial. That's what I am supposed to prove. It may be given in your examinations as, if it is given as a multiple choice, you just choose quickly by remembering this method. If in to do in explanatory method, you have to do only this way. If the power is something else, accordingly the result will vary. If I am going to equate coefficient x power n minus 1, the result will vary. And if such a question is given, accordingly you should be ready to answer. Thank you students for patient watching. I will try to upload after going through the video as usual.